this is Dr. Rainey here again. I'm going to show you today how to do the lab 9, which is radiometric dating and half-life. Before we go into the actual experiment, how to do the experiment, I'm going to teach you a little bit about what is radiometric dating and what is half-life, what is a parent nuclei, and who is a daughter nuclei. So we know that radioactivity has proven to be a reliable method to identify the numerical dates or age of the rocks, and using that process called as radiometric dating. So how this happens, how do they do that? So there is a process called as radioactivity. So what is radioactivity? Is a process in which an unstable nuclei, which has a very high energy, undergoes disintegration or decay to form a stable nuclei. That is called as a daughter nuclei. And in this process of transformation from an unstable status to a more stable nuclei, a different nuclei, and it gives away the excess energy in the form of radiation. And this process is called as radioactivity. So this unstable nuclei is denoted as parent nuclei, and the stable nuclei which is formed, which is entirely different from the parent nuclei, and that is called as a daughter nuclei. And excess energy is given again in the form of radiation. So today we are going to illustrate the same disintegration or radioactivity process by using nickels and pennies. I'm going to start. So here before I go to actual experiment, I'm going to explain what is this rate, what is half-life. The rate of disintegration is called as a half-life. So how can I explain more in a simpler way? It's the time required for half of the original radioactive substance to disintegrate is called as half-life. So I give you an example. If I have 100 grams of radioactive substance, example uranium-238, I'm just giving you a vague half-life. Say its half-life is 5 days. So what happens after 5 days? The 50% of the original substance is disintegrated. So how much is remaining? 50 grams. This is your first half-life. In the second half-life, which is another 5 days, half of this will remain. So that means only 25% of the original substance remain. How much percent got disintegrated? 75%. In the third half-life, 12.5% is remaining. The remaining got disintegrated. In fourth half-life, 6.25. So every time what you're going to do is half of each. That many half-lives have occurred. So today what we're going to do